demonstrate TCP-IP Modbus communication, and for that I'm going to use this setup. This is my laptop. It acts as a Modbus client. Modscan software is installed on it for raising the queries, Modbus queries, and this is Simatic S7-1200 PLC, and it acts as a Modbus server and responds to this client according to the queries raised. Cat5 cable is connected between the Ethernet port of this Modbus server and my laptop. IP address is 192.168.0.5 for the client and 192.168.0.1 for this PLC or for this server. So when we establish the communication between this Modbus client and Modbus server, we are going to see these commands, these Modbus commands. So let's get started. Let's configure the Simatic S7-1200 as a Modbus server. This is a TIA portal software. This is used to configure and program the Simatic S7-1200 CPU family as well as KTP touchscreen family. The program is already open. Name is given as a TCP-IP server. Okay, let's add the controller. We have this model available as a setup. Now let's add it. This is the main program. It's run in cyclic mode. This is the MB server. Modbus server is the instruction to configure the CPU as Modbus server. It is under the communication section. Drag it and drop on the working area. These are the inputs and these are the outputs of the blocks. Inputs, we need to configure the IP addresses, holding registers, and output provides us information about the server, like if there is any error, what is the status. You will get all this information in detail into the system manual of S7-1200 PLC. This is the system manual. So please refer this manual for more detail. We'll go back to our this instruction block, and we will now configure the inputs and outputs for this block. Let's add data block, global data block, Modbus config. Okay. First input is disconnect. It is new type, so disconnect. Sorry. That is boolean. Start value is false because we don't want this block to be disconnected at the beginning of the controller. We connect. The data type for connect is TCON. Here we can provide IP address of the client and all other details. First thing is interface ID. We will get the information about the interface ID. The system constants. Hardware interface ID, local property interface 164. Hence we will configure the start value of 64. This is the server ID, or we can say slave device ID. You can configure any value for this server ID, but let's configure it one. Connection type, we are selecting 11 because 11 is TCP-IP. Enter 11. Active establishment, let it be false. Now in the address area, we need to provide the address of client, and according to our setup, the client has the IP address of 192.168.0.5. Let's configure that. 192.168, sorry, 168.0.5, and remote port is 0, local port is 502. This is the port most commonly used for Modbus. Again, we will go back to the block and we'll see what else is pending. This is MB holding registers. MB holding registers, holding register address start from 40,001 up to 50,000. Whatever registers we are specifying here, we are not specifying straightly with the Modbus address, but we are specifying the registers inside the Simatic S7-1200. But whatever address we are providing, the starting address is corresponds to 40,001. Let's configure these holding registers. Active registers. Okay. It's data. Configure 100. So data 0 here, data 0 is the corresponding address, Modbus address for data 0 is 40,001. Corresponding Modbus address for data 1 is 40,002. In this way, this address will keep incrementing for all these registers. Now, we go here, we connect all these inputs and outputs. Modbus config, disconnect. Modbus config, connect. Only the registers. Let's configure the outputs, DR, NDR, error, and status. Yeah. Status. In this way, our configuration is completed. we have configured this CPU or this PLC as Modbus server, and we specified the IP address of the client for connection. Okay, now let's download this program into the PLC. It has searched the PLC, and we can see that the IP address of this PLC is 192.168.0.1. This is according to our setup program. Program is downloaded into the PLC. Now we'll see the commands from the function 1 up to the function 6. The function 1 is read coil status. If we go here, it gives us the CPU memory map for the Modbus addresses from address 1 to 8192, Q0.0 up to Q1023.7 are the CPU addresses or the PLC addresses for the Modbus address from 1 to 1000. If we go here, we can see this is the Modbus coil address, and this is corresponding CPU address. Now to read this address, we are going to use Modbus scan. This is a simulator to simulate as a client. This is a tool. This is used to troubleshoot Modbus problems as well. So we are going to use the same one, and we are using it as a Modbus client. Let's connect. Connection time remote TCP-IP. Server, and the IP address of the server is 193. Once we click OK, we have seen that this red remark has gone. It means communication has been established. Now we are checking the first function, coil status. Let's check the first 50. This is the start address, and the length is 50. Means we can see the status from the coil number 1 up to coil number 50. To check that, what we'll do, we'll force the corresponding PLC bits. Let's see here, force table. We'll add a watch table. I'm going to add .0. Drag it. Q0.0 up to Q0.6 are actual physical outputs of the PLC. So we cannot use them to read the input status by forcing them or by simulating them. That's why we are not using Q0.0 from up to Q0.6. These are also output output coils of the PLC, but they are not actually physically present, or there is no any additional output module. We can straightly force them or change their values, and we'll see that corresponding Modbus bit is turned on. If we go here, I think let's This is the coil address. So let's check the Q2.2, and we'll see that the coil number 19 reacts accordingly, or updates the status accordingly. So Q2.2, let's watch it. Currently all are false, and we can see all are 0. Q2.2 19, 0, 19, this one. So this one is 0. We modify it to 1. You can see that the file number 19 is modified as 1. If we modify it as 0, you can see that file number 19 is modified as 0. If we go to 2.3, which is the file number 20, we modify it true. You can see that file number 20 is modified as 1. In this way, we have seen the function 1, which reads the coil status of the PLC. This Modscan not only gives us the status, but it gives us the query and response byte information. This byte information is useful for troubleshooting. Now, next section we'll see the another function, read input status function. Okay, in this section we are going to see the function number 2, which reads the input status. Modbus address of inputs starts from 10,001 up to 20,000, and corresponding bits from the Simatic S7 PLCs are, we see here, corresponding bits 1001 to, they have provided much larger range, 18,192, and corresponding bits are I0.0 to I1023.7. So these are the inputs. Our PLC has I0.0 to I0.7 actual physical inputs, and rest are the only input image memory. They are available for us, but they are actually not physically present. Let's change this table to 0 post table and drag it. In function 2, this is the Modbus address, and this is corresponding Simatic S7-1200 bit. These first 7 are actual physical inputs, so we are not going to force them. We will force one of these only memory images. Let's force I2-1. Corresponding address is 1018. We'll go again in Modscan. We will select the function 2, and we'll select the length as 50. We'll get the status from address 1001 up to 1050. Now let us force I2-1 to 1. Corresponding address is 10,018. Look at the 10,018, it is 0. And if we look at the I2-1, it is also false. Let's modify it to 1. And let's check here. I1018 is 1. Let's modify it to 0. 1, again 10,018 is 1, 0, 0. In this way, we have seen the function 2 as well, which reads the input coil. Now, in next section, we'll see the function 3. Function 3 is reading holding registers. Function 3, reading holding registers. Holding registers has Modbus address 40,001 up to 50,000, and each holding register holds 16 bits, or each holding register is one word, has one word length. Now, if we go into the Smiatic PLC, holding registers are the one which we specify in this, which we specify here. The starting register is the one which has the 40,001 corresponding Modbus address. Data, we have specified these as a holding registers, array of data 0 up to data 100, and data 0 has corresponding Modbus address 40,000. So whatever we write here, so whatever the data will be available here, that client will have in the 40,001. So let's see it now. Holding registers, and it's provided by it takes integer decimals. Let's see it into decimals. Okay. Watch table. Have here register 3. Okay. 1. Okay. Currently, all these registers, data from data register 0 to data register 5, they have all actual values as 0, and we can see this value, the holding registers from 4001 to the holding register from 4005. Let's make it 6, because we have taken 6 registers in the watch table. All these have 0 value. Now let's force them some values. We see that if these values client receives in their corresponding holding registers. See here 0. Now so all these data registers now has values 1, 2, 3, 4, 5, 6. Here also we have 1, 2, 3, 4, 5, 6. We change its values and write it again. All these values will be sent to the client in its corresponding register. So you can see that its first register data 0 4001 is 1, data 1 has 1, 2, 3, 1. So all these are copied in its corresponding holding registers. Next section, we'll see the next function, read input registers. In this section, we are going to see read input registers, function number 4. the function number 4. Let's see first of all the corresponding input register addresses for the Simatic S7-1200 PLC. Refer this system manual to get this information. We can see that the inputs, the Modbus address is from 3001 and the maximum Modbus address 30,512. Sorry, this is not 3001, this is 30,001 and this is 30,512, which is the maximum address. And corresponding memory address is IW0 and IW1022. These are the input image memory addresses of the Simatic S7-1200. We know that our physical inputs are getting covered in IW0, but next input addresses are also input image memory, but they don't have any actual physical inputs to our setup. We have only one CPU which has only 8 physical inputs. So what we'll do, we'll write some values in these registers and we'll check whether these values are coming into the Modbus address, coming into their corresponding Modbus address. Let's see that. We'll go here and now we'll delete all these holding registers and all these things. Put here 0 decimal, right. Now go to function 4 and we have here table. This is the Modbus address and this is the corresponding input image memory of the Simatic S7-1200 register. Let's go here and select the input registers. Let's see for first 6 input registers from this section to this. So currently this input image memories have the values of zeros, and we will put the values that will be getting reflected here. So I won't overwrite this because this has actual physical inputs. Let's overwrite this to modify now. So 12 is moved here and we can see that this 12 is moved into the corresponding Modbus address. Let's move here 1 5 random values 7, and now these all values are moved into these registers and we'll see that they all are moved here also in their corresponding Modbus addresses at the client. The client is raising the queries to read these inputs and our server is responding and sending these values. You can see here this white color section is raising the queries and the black is the response from the our controller. And here we'll get the number of polls and how many valid responses we have received. Here this is the function 4. Okay, let's see the other functions. So far we have seen these first 4 functions. All these first 4 functions are read only. Now we will see the force single coil and preset single register functions, function number 5 and 6. These functions send the data from client to the server and write the data into the server. For that we cannot use Modscan, as Modscan does not support this function. So we'll use CAS Modbus scanner. Let's delete this all things. So this is a CAS Modbus scanner. So this was the previous we added. I just want to delete it. Okay, so everything is deleted. I just want to start over again from first step. Let's first add connection. We would like to add this connection. Here we need to specify the address of our client server. The address of our server is 1. You can see here. Port is 502 and timeout is 3. So we have added this. Now what we'll do is we will add a device. Now we know that our device has a slave ID of 1. Add this device, and in this device we'll add this function number 5. We'll add the command for the function number 5. Function number 5 force single coil. So this is the function number 5. Here again we can force, or we can write data from the client to server, and the address is same, the coil address from the range of 1 to 10,000. Here we can see that the range 1 to 10,000 for the coil, and corresponding address of the Simatic S7-1200 PLC is from Q.0.0, and it goes on increasing. Let's first of all write the starting address is 1, and length is not, because we are only able to force single coil at a time. We need to provide a value between 0 or 1. So first of all, let's provide 1 and add this command. We'll add one more command for same, where we will turn this coil off. Now we know that we have added coil address 1, and coil address 1 is corresponds to Q0.0. So whenever we send this command, Q0.0 output will turn on, and whenever we send this command, Q0.0 output will turn on. Let's see by sending these commands. Okay, now it has done. Now I send this write single coil 1 and value 1. Now I'll send another command which will write 0 value into the coil number 1, and our output will turn off. I'll turn it on again and turn off. This is the command we write from the client into the server. In this way we can write data from the PC or from your SCADA software or whatever HMI or anything to your PLC. This is the function number 6. Now we'll see the function number 7. Let me see. Function number 6, then function number F6, not 7, F6. It precedes the single register. Let's see now function number 6, which precedes the single register, or write the data from client to the server into the single register. And here we have the register addresses. Data 0 is corresponds to the 40,001. Let's map them. 0, a few of them. Right. Let's go here, edit task. Now select the device and write. It will take a force single register. Take the register number. Let's take the register number 3. Then its address becomes 40,003, and 40,003 is corresponds to data 2. 3. Okay, and we are writing the value 113. Okay. Let's take the same example. Force reset single register. We take the same. I will write just another value. Now we can see that this 4003, 401, 2, 3, data 2 has this value. When we enter this command, 113 will be moved. 113 is moved. When we press, we can send this data. See that 1212 is moved. So here we are writing the value from the client to the server, or from the PC into the PLC data register using function number 6. This is the response also you are getting for troubleshooting or something. Now let's see the next function. Okay, now let's see the next function. The function is to force multiple coils. Here we are forcing the single coil at a time. Using the force multiple coils, we can force multiple coils in single command. Let's add the task, select the device, and write, and select the force multiple coils. This length is enabled, so the starting address is 1 of the coil, and let's make the length. We have total 6 inputs, so make 6 outputs. Let's make the length 6, so all the outputs will be on. We'll add one more command to turn them off. Sorry, select device, edit. Right. Address 1, length 6, and we are writing 0 to all of them. So we can write 1 to all the 6 coils, and here we are writing 0 to all the 6 coils. So okay. Here in the PLC, now you will see all the lights, all the LED lights of the output from Q0.0 to Q0.5 turns on when I send this command. See, all this turn on. Now when I send this command, they all will be turned off in single command. This is a forcing. Okay, now the next command is input registers. Let's add the right command for that. Here force multiple registers, and we make the starting address as 1, and let's make the length 5, and we'll write 1 2 1 2 in that all these 5 registers. We'll add one more, sorry, add one more command, post multiple registers, then 5. We'll add here some more another values. Okay, go back here, and we have already these registers here. Data register 0 corresponds to holding register 4001. So when we put the command here, first 5 registers will have 1212 value. Let's put it. Let's see what happens here. You can see all the first 5 registers has values 1212. It is in single write command. We have sent the data to multiple input registers. Now we will send the data 1 2 3 to all these 5 registers in single command. 1 2 3 1 2 1 2. So using this function, we can write the data in multiple input registers.